Good afternoon, everyone. If you are here because you're interested in how Google DeepMind is doing innovation and how Google Cloud is bringing that to you, you are in the right place. My name is Advait Bopardikar. I am the outbound product manager for all of the model capabilities that are available on the Gemini Enterprise Agent platform. Today, I'm going to talk a lot about our strategy, about what we want to bring to our customers. Later on, you're going to hear directly from Philipp from our DeepMind team. He's going to talk a little bit about the Deep Research API that we're releasing today, how it works, how the team works. And then later on, you're going to hear from Patrick, who's from FactSet. He's one of our customers who started off by trying and giving us feedback on the Deep Research API. You're going to hear about how customers are actually using this capability, the value they're getting from it, and the value that their customers are getting from it. So to get started, a little bit about our strategy, a little bit about how we think about innovation. There's something magical and different about the way we do it at Google. We're the only provider that has this full vertical integration across the stack. And then when we think about innovation, we think about how do we do it at every single layer in that stack. So you have the teams that are building all the hardware. The hardware is being used to train models. The models are being served on a platform. That platform is being used to build agentic applications. Across the layers, we're thinking about how do we co-innovate at each one of these layers and make improvements across all 5. Now, on top of that, what we're really going to focus on is the research models and the platform that we're bringing, and really about how we make things better, faster, and cheaper for all of you. So to really understand the agentic platform, for those of you who didn't see the keynote, I think it's important to understand how software engineering is developing over time. In the past, this is my personal opinion, machine learning was always actually about adding agency into software. It was just at a different scale than it is today. You may have created a demand forecasting model, a fraud detection model, a spam detector like we do in Gmail, and you're largely thinking about how do I then embed that into deterministic software and have the software do a task on behalf of me that I could not have done otherwise at scale. Today, things are a little bit different. We have generative models, they're general purpose, they can reason at scale, they can use tools to complete tasks on your behalf, and now you give them an agentic harness. Rather than rules, you allow them to play. There's a bit more flexibility and fluidity in the way that they behave, but if you want determinism, you can certainly do that as well. So this is changing the way that you're designing things, but a lot of the problems are still the same. And that's why this evolution is really an evolution. Vertex is becoming the enterprise agent platform because there are common issues, but there are different solutions. You're still needing to think about building, but instead of building models, you're building models and agents. Instead of scaling models, you're scaling models and agents. Instead of governance of models, you're now doing models, agents, tools, and the data that the agents are playing with. And finally, when it comes to optimization, you're always thinking about how you can make things better. Data drifts, user behaviors drift, agents get better over time. How do you actually make improvements there? Now, for us, if this is our goal, if this is how we want to make things better for you as our users, what else can we do to make things even more optimal? Well, one solution might be, why don't we just create the agents on your behalf? Instead of you thinking about building an agent and scaling it and governing it, can we do that? Can Google do that? Because we built the model, we know exactly how it performs, and we know how to scale it and deploy it on our own infrastructure. So that's exactly what we're doing with the Deep Research API that we released yesterday. So hopefully you all get a chance to play with this. This is available on the Google AI Studio today, and in the coming days, you're also going to see it show up inside of the Gemini Enterprise Agent platform. What the Deep Research API allows you to do is get the same experience you have inside of our consumer Gemini app, as well as the Gemini Enterprise app, but now developers get access to an API where they can embed that functionality directly into their own applications. So now you have search results that are coming from the best search engine on the market, but on top of that, you have the ability to combine it with your data through a MCP server, or you have the ability to retrieve data from trusted third parties who have high-quality data that is proprietary to them. On top of that, inline graphics. Sometimes a wall of text is not the right solution to consuming information. At least it's not for me. I'm a bit more of a visual learner. So now Gemini can use its coding capabilities to create visuals for charts and graphs. And it can also use the Nano Banana model to generate interactive or engaging infographics that explain complex concepts as visuals. So why might you want to use the Deep Research API? And why do you want to think about using any sort of Gemini-based agent that Google is creating for you? Well, one of the reasons is we know how to really work with this model and get the best out of it. This new API is not only new functionality and an API interface, it is also improvements in the quality of the way we perform deep research. So we're seeing massive improvements in terms of its factuality, its groundedness, its ability to retrieve facts that are difficult to source. And it eliminates a lot of the experimentation for you. Rather than you figuring out how to run an eval, how to test, get quality out of it, you just have to consume an API, and you no longer have to think about all the complexity of building out a functionality like this. Now, another piece of information around how this helps you out is the fact that research is complicated, right? You need to find hundreds of sources, find out which ones are reputable. After that, you need to find the important information that helps prove the point that you're trying to make, extract those insights, synthesize it into a report, make visuals, provide citations. You will spend hundreds of hours, maybe thousands of hours, thousands of dollars doing this task by hand. The Deep Research API simplifies this for you. You move from something that was time-consuming into something that happens in a matter of minutes and is only a couple of dollars. So that's really the power of thinking about, well, what can Google do for you by building agents, whether it be today's Deep Research agent or any other capability that we're going to roll out in the agent platform for you in the near future. So I think that's a little bit enough about the high-level strategy. We want to get into the technical details. So we're going to call out Philipp from our Google DeepMind team to get hands-on, see the details, as well as do some demos.
Hi everyone, my name is Philipp. I'm part of the Google DeepMind team working on the Gemini API and also on the Deep Research API. So I will start a little bit talking about how we build the agent, what it does, how it works, and then we go into some nice technical demos on how you can start today, how you can build with it, how you can let your agents build with it. So building agents at DeepMind basically all starts with our reasoning core, which is the Gemini model family, which is built to reason over multi-step complex problems. And we also use post-training to make it better at search, right? When you search at Google, you might type something in and very basic models just try to summarize it and give you the result of your search. But what Gemini does, especially in the Deep Research API, is that it tries to reason over your searches. So it might start with some exploration work where it starts multiple different queries for specific topics, and then based on the results, it continues to go deeper into all of those certain topics. So if we compare it to a standard LLM call where we have a query, our model generates something, and then we have the output. In our Deep Research agent, we first start with a plan. So based on your user input, the model, or we have a planner, basically creates a plan how best to approach this task. You can iterate together with this planner to improve the plan based on your needs, based on your feedback, and then we go into the searching. The searching consists out of the search. The results basically are read by the model, and then it reasons over it, and this ends up in a loop. And after the research is done, we have a separate synthesize process which creates those nice little reports, and also now with the visuals. And the results speaks for themselves. So the new Gemini the Gemini Deep Research Preview agent, or Max agent, achieves 55.6 on humanity's last exam. That's basically, as the name suggests, a very complex benchmarks, trying to achieve very complex tasks. Browse.comps is basically a search benchmark, and Deep Research QA is a benchmark coming out of the DeepMind research team, which tries to solve or lets us evaluate very complex search topics. So if we look at under the hood on how the Deep Research agent works, the first step is we have our meta planning phase. So basically the agent tries to decompose your query, creates a structured plan, and then starts the search queries. We have the research loop, which consists out of the research, reading and reasoning over the results of the research, and then repeating it until it feels we completed our structured plan. The third step is the synthesizing. So we have create a draft, we verify our sources, make sure we have citations, and then we create our structured output, which is then presented to the user. The very nice part about it is that you can connect your own data. So it's not all about the web search and the context from the web. You can use file search. So in the Gemini API, you have access or the ability to create your own RAG store, so to speak. So you can upload your own internal PDF data and then connect the Deep Research agent to your own file base. But also now, since yesterday, you can connect to remote MCP servers, where we work with different partners together to make it very easy to get data from very domain-specific providers, like finance, for example, or if you work in agriculture, there are now specific providers which allows you to connect your data to those MCP servers. And then also the agent is built with resiliency in mind. Deep Research requests run not just a few seconds, right? They oftentimes take minutes or even hours to complete. So we solve this by managing the state on a server. So in case your connection drops or you walk away from your computer, all of it is kind of stored, and you receive event IDs, which you can then use to reconnect to your deep research request, or you basically have an overall ID which you can use to poll the request. So how can you use it? The deep research agent is available in the Interactions API today, and the Interactions API is our new API, or a unified API, to use models and agents together. And unified here means that you can really use a model and then like follow up with a deep research request, or you can take the output from a deep research request and feed it, for example, into a Gemini model to translate it into like German or into another language to ask follow-up questions, or even use the TTS model to convert your deep research request into a podcast if you like to listen to it. On the left side, you see basically how easy it is to get started using a model, and on the right side you have the same kind of API interface but with the deep research agent. So the only difference really here is you change the model parameters from the Gemini model to the agent. The input basically is the same, and since deep research requests run for a very long time, we added support for background, very similar to other available APIs. Background true basically means you start your request, it continues in the background, and you can like check from time to time, is it already done? Or you can also enable streaming to get like thought summary updates while the request is running. So we already quickly talked about the capabilities, but here's a quick overview on what was available until yesterday, basically, and what is available today, or then like starting in a few days. So it's available on the Interactions API. It supports asynchronous execution, which means you can start it, you can come back to it later. It supports multimodal input, so you cannot only provide a text input. For example, if you have already a PDF or an image which you want to use to create a plan or to create a research, you can provide it. You can steer your report. That's something which we are going to look in a second. So if you prefer a specific format of your report, so for example, you always might want to start with an execution summary at the beginning of your report, or you prefer tables over bullet points. You can all provide this via prompting. Support for inline citation. This means all of the paragraphs, all of the sources are inline quoted, so you can easily like look up where the information is coming from. You can do follow-up questions to a model. You can stream the thought summary, so while the research is running, you can get intermediate updates, what is this currently doing, where it is currently going, and you had support for Google Search URL and file context. And starting today, we now have support for code execution. So if the agent thinks it benefits from running some Python, doing some math, basically it can now use Python to extend your report. We have support for charts and visualization. That's also something which we're going to take a look. It will be soon available on the Gemini agent platform, and it supports collaborative planning. That basically means that you can together iterate over the plan before starting the research, and it has support for remote MCP servers. And we are like not working alone, basically. We have many great partners, especially from the financial ecosystem. FactSet is also here. Patrick will speak after me to show you a little bit more on how they used Gemini Deep Research, how they integrated Gemini Deep Research into their stack, and also how they provide an MCP server for you to build on top of the FactSet service. Okay, so all of the things which we are going to see in the demo is available for you to test, so you can find it on the Gemini API documentation, or there's also a cookbook which you can open in Colab. Very easy if you just search for it. I can also show you in a bit, and I think we can get started. Okay, perfect. So I'm in AI Studio. Currently, I'm not sure, has anyone of you used AI Studio before? Maybe a quick, okay. That's a lot of few hands. If not, the easiest way to get started with AI Studio is if you go to ai.dev or ai.studio, you end up on AI Studio. You can use your normal Gmail account. If you have a Google Cloud account, you can use it as well. And it's the easiest or quickest way to get started with deep research. We have a playground. In that playground, you can use the different agents. So we have Deep Research Preview and Deep Research Preview Max. The Max version is basically a more intense version which runs longer research, explores more options to create a more deeper request. So what we are going to do is like I link my API key, and then I can start a research. I can also configure the tools I want to use. So I can say, okay, I want to use code execution, I want to use Google Search and URL context. And we will start a query, and then we will see if it completes until the demo is done. If not, I have something prepared. So we can start very simple. Maybe we can research the topic, the new features from Google Cloud Next 2026. Let's see how good our research will be. And now what happens behind the scenes is we started our research. We have streaming enabled, so we will, as soon as the agent starts, it hits work, we will see the updates. And I already run something earlier, like you can see today, like roughly an hour ago. I asked, okay, if it can like do some research on the last 10 football World Cups, including visuals and infographics. 2026 is the World Cup in the US, so I wanted to see, okay, what can I learn about it, what can I expect? And the research here took, not sure if I can still see it, but I think it was around 23 minutes until it completed. And we have the thought summary. So we can see, okay, the first step was it generated its research plan. It then identified the different sources. And then we can look at the result. I mean, I will not read all of it, but we can scroll a bit and see. So for example, here it generated a visual for the goal scoring efficiency versus tournament expansion, which is very nice. And in addition to this, let me close that. There was another one which looked very interesting. So we have the tables with the different years, which hosted it, how many matches was played, how many goals were scored, the average goals per match basically, and the attendance. And there was also a very nice, no visual here. Okay, so to have you all started, we have this cookbook. The cookbook is basically the programmatic way to get you started. It's also available if you prefer JavaScript or another language to use the Deep Research API with it. In this case, I will use Python. We will get our Gemini API key. We install the latest Google Gen AI SDK. That's our Python SDK to get started. That's also the same SDK which you will use with the Gemini Enterprise Agent Platform, or which you might have used with Vertex AI before. And we will create our client. And since we don't have 25 minutes for the demo, what we are going to do is we look at the collaborative planning phase. So first, I need to select my agent. We go with the basic version. We run some helper function that we have some better outputs. We will not run the first deep research task because we don't have the time, but we are going to look at the collaborative planning. So the collaborative planning basically allows you to stop the agent after it generated its plan. So I can start a request here. I have my research query, which is research Google TPUs versus competitor AI accelerator hardware. And it also runs it on a background. I can enable it with the collaborative planning true flag. And it should take around maybe like 10 more seconds. We can see the status is still in progress. And then we can refine the plan. So basically based on the request which we receive here, so we have our, let me make it a bit bigger. We have our title, we have our input, which is the query, and then we have the research plan. So the first step would be identify the latest generation of Google TPUs and outline their key specifications, and then we have many more steps. And let's say we want to have a separate section on comparing the power efficiency and the total cost of ownership. So what we can do is like just send the same request. Here we use the previous interaction ID. This basically means we append to the previous request. And we say, hey, still collaborative planning true, add please a section on the total cost of ownership. And then we wait a bit. And assuming our plan is okay, that's something we want to go with, we turn the collaborative planning flag to false and provide an input with the plan looks good. Okay, our plan finished. Let's see if we have, yeah. So we have point 6 is now conduct a dedicated comparison of power efficiency and the total cost of ownership between Google TPUs and competitors. So together with the planner, we basically updated the plan based on our needs. It saves a lot of time because if you don't have planning and just start something, you might come back after 20 minutes to find your research complete, but you maybe find missing pieces of something which you would like to know. We can start this as well and let it run for a bit. Same in the notebook, if we want to do some visuals, we can explicitly enable them, but we can also prompt them. So we can say as part of our prompt, hey, analyze the global semiconductor market trends for 2020 to 2025, and include charts showing the market share and changes between the top vendors. I already ran the request. We get all of the reports, but also we get some very nice visuals. So we have the NVIDIA captured market leadership as traditional vendors lose ground. We have a very nice visual for it, and all of that is done automatically. So if you, for example, prefer to have a certain CI, you can include it in saying like, hey, focus on bar charts, focus on pie charts, focus on like flow charts, for example, if you want to have some specific needs, and all of them is like integrated into the report. It also supports real-time streaming. We have seen it. Maybe you can like quickly look back to our, okay, that's cool. Our initial request was completed on the new features from Google Cloud. And now the report here took 5 minutes. So it really depends based on how depth your query is, how long the agent will work. Like the overview about the World Cup and the top scoring took 23 minutes. Here it was a very quick report. It only researched 46 sources, took 5 minutes. We can also take a quick look to see if Google is already updated based on the announcements this morning. I cannot see something new. Maybe we should run it later again when all of the indexes are updated. Going back to our notebook, we can do streaming, where you basically receive the same thought summaries which you might know from Gemini to render it to your user to keep track of what is going on. And then you can also configure a tool. So now you have the complete flexibility on what your deep research agent should use to create your report. You can also just say, hey, only use Google search. I don't care about specific other data. You can say, I want to use Google search, URL context, and code execution. URL context is basically allows the model to go to specific websites and like try to read the whole context from the URL. You can connect your MCP server, so if you have a remote MCP server internally, or if you have a provider which you work together, you can connect it, and you can also configure the tools you want to use, right? Some MCP servers come with many tools, and you might only want to use a specific tool set or tool from this remote MCP server for your own research. And then similar, we talked about file search, which allows you to create your own RAG store inside of Gemini, and for the Gemini Agent Enterprise platform, you can connect it to your Vertex AI store. So file search is on the Gemini API, the same as the files AI search on Vertex previously. And then also for providing images or multimodal data, you can provide your text prompt, but you can also provide an additional image, which then the model uses to create the plan and to create the report. The same goes for the documents. And then also for the steerability, which we talked about it, so you can be very specific on what or how you want the research to look. So for example, in this case, I told it, hey, I want an executive summary, max 200 words. I want a table with the key players. I want to have an outlook at the end. Sadly, I don't have the result anymore. And we can also do a follow-up. So if you run a research and you want to like don't read it and just like try to extract some bullet points or try to ask some follow-up questions, you can like switch to the Gemini model and then like just asking about it. For me, the nicest use case is if you take a deep research request and then use the new Gemini 3.1 TTS model to generate a podcast, which you can then nicely listen to where you walk or like drive with your car. I have also some more examples on how the reports could look and some visuals to give you some more insights. Here we have a pie chart generated based on the initial query was like research the growth of enterprise AI service across AWS, Azure, and Google Cloud in 2025 and 2026. We got a pie chart, we have tables, we have all of the data. In the blog post which we released, there's also some more examples on how those visuals could look. So here we don't have a chart, we really have something more concrete, a pie chart, and other visuals, which we will see later a bit more. And we have a great documentation, so if you want to read about it more, if you want to dive deeper, if you don't use Python, if you use JavaScript or REST or any other language, it's the best place to start. And then also, I mean, I don't code much anymore. I use Coding Agent, which helped me to code. We have a very cool skill available for the Gemini's enterprise agent platform, but also for the Gemini API, which you can use to install and then provide it to Anti-Gravity, to Gemini CLI, or to whatever coding agent you basically use, and tell it like, hey, please help me create a demo for the Gemini Deep Research API. It will build it for you. You can ask the query. You can like run it with it. It makes it very nice. Okay, thanks for the demo, and I hand it over to Patrick to talk to you more about how we work together.
All right. Hello, Google Next. Very excited to be here. Very excited to follow these gentlemen talking about what we are doing here at FactSet and the collaboration we've had with Google around the applicability of deep research within the financial services space. So my name is Patrick Starling. I'm a senior vice president, senior director of AI product management in FactSet's AI Foundry. We're helping to transform FactSet with the speed of AI. And if you're unfamiliar with FactSet, we are a 48-year young financial intelligence company. We have all sorts of solutions across the financial services space. We service over 250,000 users every day across 9,000 investment firms, 12,000 people. And what we've always done historically is we've been one of the leaders in multi-asset class financial data. We started as a content aggregator 45 years ago. We didn't collect our own data, but we built great user experiences on top of that information for our users. And that has really allowed us to become a trusted platform for investment professionals around the world. And as we're embracing AI, we're trying to bring all of the crazy, powerful, awesome abilities of these new LLM models to the types of workflows that people use on our system every day. And over the last 10 years, we've really embraced a philosophy of being open and flexible and not just constraining our data and analytics within our software, but also exposing it out through things like APIs, cloud, feeds, and nowadays things like MCP, so you can easily bring that type of intelligence directly into powerful tools like deep research. The types of clients that we service across buy-side asset managers, insurance companies, pension funds, hedge funds, investment banks, private equity, venture capital investors, wealth managers, and there's a whole fintech and partner ecosystem that also needs financial data, needs to trust the content. That is absolutely critical for them because at the end of the day, they are making huge financial decisions both with their own money but also their clients' money, which is often all of our money invested with them, and millions or billions of dollars are made or lost based on those decisions. So therefore, data accuracy and trust is absolutely critical as we come into these new platforms and paradigms. So we've been working very long over many years as to how do we advance these types of research capabilities. We've been recognized for that in sort of the pre-AI era. We're starting to be recognized that in the AI era. And so now deep research models give us a really whole new, very powerful set of capabilities that we can also bring to these users. So how do we go about doing that? So the most important part is how do we source all of the content? How does the trusted data come together? This is one of our sort of secret sauces, and it comes from how we ingest huge volumes of documents and process them and turn them into the data products that flow into our solutions every day. We ingest tens of thousands, hundreds of thousands, sometimes millions of documents every day. These come from newswires, from filing sources, from investment banks, from their research reports, from regulators, from data that we scrape from company websites, you name it. That flows through what we call our data refinery. In that data refinery, we align entities. We make sure that if you're talking about a large company like a Google, right, there's a lot of different parts of Google. There's Google Inc., Google LLC. There's a lot of different share classes and subsidiaries and other things. When you look at all that low-level financial data, how you actually stitch that together and make sure that you can tie it all together is critically important, because these are things that, you know, models are increasingly good at telling it apart, but on the other hand, I need accuracy. I need to know that these things truly do line up. The next is the data. Across all these different data sources, if we're talking about revenue versus ASV versus contract value versus all sorts of things, we're often talking about the same thing, but it means very different things in different contexts. So how you tie that together through data ontologies and semantic layers becomes critically important. So that's how we take the data refinery and turn it into powerful unstructured data products such as news, filings, transcript sources, structured data products like company fundamentals, estimates data, M&A content, people, deep arrays of very deep sector, industry-specific type content that powers the intelligence solutions that our clients need. And then we align all that content across a whole other data ecosystem that comes from exchanges and other third parties that participate in the financial space, and that data all needs to be aligned. And historically, we've delivered across software meant for human users, things like our workstation, our mobile app, but increasingly feeds, APIs, and nowadays MCP. So if you haven't had a chance to play with financial MCP in context before, here's a quick example of our MCP running inside of Gemini. So let's say I'm a user and I want to help understand JetBlue and their competitors and how they've managed fuel expenses over the last 10 years. I could go and find this data in our workstation. I could build an Excel model using our query language. But this is a really great way to use standard LLMs to do this type of data QA. I can pull the data in. The LLM will help me synthesize. It gives me a really quick answer, the sort of thing that would have taken me much longer to pull up previously. We might have other examples like we want to dig into Amazon's M&A activity and help summarize all of that for me. Ooh, we went a little quick there. That's all right. But now as we go beyond just data chat, how do we actually go from chat to providing real acceleration for the investment professionals who are using these tools every day? This is where I think these deep research models become really, really powerful, because we want to move on from just answering questions for users or building sort of more basic bots to things that allow users to operate at machine scale. Right? Everything you hear in today's keynote and in a lot of these new product innovations comes down to the fact that the machines are moving faster and faster, and we want to augment the humans with the same type of capabilities. So let's think of the workflow that a lot of investment professionals have, right? I'm riding on the train in the morning, I'm going to the office, my day's full of client meetings, but I'm listening to a podcast, maybe that I've generated off of another great research tool, and I hear a new idea. I'm listening to a podcast on AI, and I hear that, hey, when you look at the neoclouds and these other people are providing augmented compute for the AI revolution, they may have some financial challenges ahead. Is there an investment opportunity here? How do I understand that space? I don't have time to walk in and start researching this today. I want to pull at this thread. I want to understand very quickly where this goes. So I could use these deep research models to ask these sort of detailed prompts that would dive into all of that and would use that structured and unstructured content to really go deep. So let's say that my hypothesis is that, hey, CoreWeave and the other neoclouds might be cash crunch in the future. Heard it on the news. Help me dive into their profitability and long-term financial health. Let's use FactSet's MCP as a place to pull in all of that sort of structured and unstructured content. Let's dig into how these companies are funded. Let's look at their revenues versus expenses. Let's look at what they say in their earnings calls and regulatory filings. Let's look at what the street has said about them. Let's look at their supply chain. Let's look at who else they're working with. Let's look at the health in the VCs and the BDCs who are funding them. Let's look at insider activity and what other type of market activity might be happening to tell me, is there a canary in the coal mine here? Challenge me. Tell me if you think I'm right, if you think I'm wrong, and where else I can go and research this topic a little more deeply. Fantastic type of workflows. And so as these research reports go and run, they can build these visuals, they can help me understand the walls and walls of data that are going to come out of these models. And in the end, I'm going to get these powerful reports that I can start to interact with. It could be a write-up like we sort of have here. It could be visuals and dashboards. There's a lot of really powerful new ways to help synthesize that data. But I can now take a look at this and I can see, hey, how's the institutional money moving into this trade? What are the big questions that we want to look at? And now I can say, hey, is this an idea that I want to go and put my research team on if I'm a buy-side company and dig further and further into? Because I'm going to need other humans or other agents to dig further before I make a decision. Or if I'm an investment banker, is this an idea that I want to go and pitch somebody on? Should you buy this thing? Should you sell this thing? Those are the type of workflows that are really meaningful for our users in our industry. So this is where I think deep research is really, really powerful, but it's actually going to go a long way to where we can go in the future, right? The models provide a lot of really powerful capabilities, as Philipp was just taking us through, in terms of how we can have the models autonomously follow the thread and do all that planning. They can do the multi-source triangulation, right? They can look not just at our structured data, but let's get the unstructured data, let's scrape the web, let's look at our other internal sources, and let's see where does it line up, where does it not. The dead-end type of handling and the synthesis across time frames and time horizons of different data types are really powerful. So that's where the next horizon we think with these models lies as we go beyond regular elements to deep research models, is we can accelerate the types of structured data flowing to these models through MCP. We can tap into the large universes of trusted and enriched unstructured data. And then I think the really big thing, and this goes back to Advait's lead off at the beginning, is bringing AI on top of deterministic systems. How can we tap into the other types of engines and tools that we have in our industry? We have things like powerful backtesting engines, quant engines, risk engines, portfolio simulation engines, programmatic quant environments, where not only can I go and research this topic, but I can actually go and backtest this idea. I can run a portfolio simulation, I can balance out these things, and I can do that over and over and over again at machine scale in a way that would take humans, the human users in our industry, days, weeks, or months to do today. So we think that's really, really powerful, and we're really excited for where we're going to go with our partnership with Google and take this to the next level. So to conclude today, we're going to leave you guys with a couple words from a couple other AI leaders, including our Chief AI Officer, Kate Stepp.
Google's just released a new update to Gemini Deep Research, and we've seen a massive jump in capabilities. The first things that struck us were the speed and the exhaustiveness of it. It's made it possible for anyone to ask and answer heavy-duty scientific questions that require evaluating all of the scientific literature, and it lets us answer questions in days rather than waiting weeks or months.
What deep research is able to do in an impressive way is connect that quantitative data to more qualitative data and really bring that to life. FactSet was an early adopter to a more open approach and an open ecosystem. In our industry, trust is the very critical piece. You can have innovation and the most advanced features, and if the data is not rock solid, our customers will not use it. Bringing more of an AI-ready approach to that data allows it to be integrated into solutions like deep research in a way that really helps us ground the answers and bring confidence to our client base.
Axiom's goal is to help scientists understand which drugs are going to fail in clinical trials before they do. The data about drug toxicity and clinical outcomes of drugs is buried all over the place. And often what you need to know is at page 80 of a very long PDF. So Gemini Deep Research's ability to access data from all sorts of modalities has been extremely critical to us.
Our industry is all about alpha generation and really finding insights in unlikely places. So the multimodal factor, being able to kind of bring in sentiment from video, voice, look at text, bring in quantitative data, all brought together in one place. It's just a richness of the narrative that is much more advanced than research of the past. When you think about the amount of processing that can come through deep research across all of these sources, that really unlocks the expertise of a human to bring out the nuance, focus more on how you relay that information to clients or peers, and bringing a human element. This is a huge shift for the financial industry because of how much they have wished for productivity for so long.
Deep research has really accelerated our team. It saved us from having to build out really complex workflows, lets our scientists iterate extremely quickly, and it lets them focus on what questions they want to ask.
The number of ideas that could come to fruition, the quality of those ideas, and the way that new insights deliver results for our client base is a huge way that research is shifting. Just allows a broadening of scope that an individual human wouldn't be able to achieve.
It's superhuman.